Knows. Abby and Ish are Batman. Abby's here, but Ish is not. Ish is here and Abby's not.
Where is Abby?
Don't know. She's in the hall. Last I saw her, she was talking to her mom and then she vanished.
Okay.
And then she saw her in the hall. I have no clue.
All right. Everybody's got a sheet of paper?
Yes.
Okay, I'm gonna teach you something you already know how to do. But you already know this, right? The only difference is we're doing it with trig functions. But you already know basically this is transformations. Graphing a function by hand using transformations. So you already know how this is done. Oh, that was no questions. Make sure it wants from the box. We got nothing until after we get back from that 3-day weekend, and that'll be a quiz. And I'm just going to do a review and quiz. I'll throw a couple things that we're learning on this along with the stuff from chapter 7. All right. This will make more sense once I teach it to you. I only want you to graph one cycle. You can graph more if you'd like, but you only need to graph one cycle. Graph paper doesn't really make it that much easier. You can use graph paper, but I'm saying it's not like, oh, I got a graph, I need graph paper. You can do this by hand really quickly. I'll show you when we get there. Yep.
This morning while driving back to the window.
I think it was probably when I got out of the car that probably when I grabbed the door because it was windy and I kind of pushed down on the electric window openers probably. I'm guessing that's what I did. I would have noticed if I was driving. But thank you. I would have gone this afternoon. I would have gone to my car, have been full of snow. She came to me, she goes, hey, your window's down on your car. All right, good, everybody? This is quickly done. Like this isn't much homework at all. Well, you could do that, but I'm going to show you how to do it by hand. You need to be able to do it by hand, so you could certainly plug in your calculator and check your work. All right, good? All right, here we go. So today we're going to be graphing sine and cosine. Tomorrow we'll do the other functions, but this is graphing the stuff by hand using transformations. Okay, so it's pretty straightforward and easy class, right? We've seen this many times in this book so far. I give you a function and ask you to graph it by hand. You look at what the parent function is. You have some special values for the parent function, and then you apply the transformations to the parent function's numbers or special numbers. That's big picture what we're doing, right? We are going to be doing the sine and the cosine, so you need to have good familiarity with the unit circle to understand where this all comes from, right? And it's essential for trig that we always have our unit circle handy for us, right? We've also seen that for this chapter, being familiar with the basic shape of the 6 basic trig functions is also important. So, like, I'm just showing you pictures of these 6 trig functions. Eventually, hopefully, you know sine and cosine, and you know tangent kind of has some wiggles. But the cosecant, the secant ones are the ones that you probably don't have good command over yet, but we will eventually. All right, so to help you with understanding of what are the basic shapes, we have 2 days devoted to just graphing those shapes, right? So basic graphing the basic 6 trig functions, right? We'll do sine, cosine today and the rest tomorrow. All right, so let's graph them, right? And we're gonna do it by hand. Yes, you can use a calculator to check your work, but this is meant to be done with your hand, right? Turns out that the unit circle causes a little bit of confusion when we graph this. Hey, everybody see the numbers that go around the outside? They look like points, right? They are points, but they are points on the unit circle, right? They are points on the unit circle. We're doing a graph, but we're not going to graph the unit circle. That's just a circle. We're going to be graphing, we're graphing these things right here. This is what we're trying to produce, the actual physical graph of the sine and the cosine function, not the unit circle. But it comes from the unit circle, those values, not the values that go around the unit circle. Those are just literally the x to y coordinates of these dots that appear around the unit circle. right? What we're going to be doing is graphing this thing right here, right? I put the y on the other side because I want you to remember this as a point. Remember, points go x, y, right? So the y, well, the y is the y, but the x value is your input of that equation right there, your theta value. So your input is this x value. And if we put an input and we get an output and we graph those, we get that shape of that sine wave right here. All right, so that's the basic idea. So I want you just for a second ignore much of the outside and just focus on the inside. The inside has angles. And from our equation right here, angles are the input. So if I input 0 degrees into this function, sine theta is equal to y, then my output is your y, well, the y value is 0, right? So I'm actually not using this x value. I will when we do cosine, because remember, cosine is defined as x. Okay? So I take those two values right here, this angle and this 0, and I put them together, and that's my point. And you're like, wait a minute, how can an angle measurement be the x value be a point? Well, it is. It's the input. So wrap your head around when we graph this sine function and the cosine function, that the x value will always be an angle. In this case, 0 degrees, right? 0 degrees is still a number, right? The y value comes from literally the y values on the unit circle. Okay, cool. And then I'm going to go around the unit circle and grab the very next one. The next one is 30 degrees. I could use radians. I could use degrees, whatever you want. So I grab the next one, 30 degrees. I look at the y value. The y value is, and there's my second point. And then I repeat that process all, I'm going to not do them all. Notice I'm not writing square root of 2 over 2. I wrote 0.7 because we've got to graph this thing. So where is the square root of 2 over 2? Well, I've done some rounding here. Same thing with root 3 over 2. That's 0.9. It's not 0.9, but I think it's 0.86. But I rounded. See where I'm getting those numbers from? And I go all the way around. I do that. In fact, I can go the other direction too. I could go in the negative direction. So 330 is how many degrees in the negative direction? 330 degrees would be what in the negative direction? Negative 30. And so negative 30 would still have a y value of negative half. Okay. I only showed you a few of these, right? So that thing when I say I want you to draw one cycle, I just want one sine wave. I don't want lots of them. I take those values right here, I put them on a graph, and I graph them, right? And you're like, well, how do I graph that? Well, think of these as tick marks. Think of the x values as tick marks. So we got 0, that's the origin, right? And then I got a first tick mark, second tick mark, third tick mark, fourth tick mark. If I want to graph this one, 5 tick marks. So if you think about this graphing it by hand, instead of thinking like, well, do I literally need to go to the number 30? Yes, you're going to label it 30, but it's going to be like the first tick mark, right? After 0. Your first tick mark is going to be now 30 instead of 1. Does that make sense? So don't get overwhelmed by this. And by the way, I chose degrees. I also could have chosen radians. You're going to see me go back and forth between degrees and radians, right? So this graph actually did it by radians, right? They're pi here, right? But you get the basic idea. So this is one complete cycle right here. Okay. All right. So we're going to do this now, and I'll show you the whole process, right? So if you look at box number 1, right? It has a table, right? So we're going to fill that in. By the way, also, for those of you that on the unit circle, remember we draw this triangle right here. Those are the values that go around the unit circle. Those are literally the x's and the y. So for instance, at 30 degrees, this angle right here, the x value is 3 root 2 and the y value is a half. So that's where, I don't know where that comes from. We're not doing that. We're graphing the sine function, just the sine function, not the unit circle, but the sine function. And the sine function comes from an input x, which is the angle, and the y, which is the y value that I had highlighted here in red. Okay, so I'm going to get rid of that right here, but to graph. So we don't need that triangle thing right here in order to do our work. So for instance, 90 degrees pi over 2 is your x value, your input, and the y value is 1. Okay, so red is your input, blue is your output. Okay, cool. Now ignore the unit circle itself right here. We're just focusing on this table. In box number 1, I'm going to choose almost all the values. I want you to write them down here for x. I'm going to skip all the 45 degrees. It'll make sense here in a second. So write this down. So I went 0, pi over 6, pi over 2. Notice I'm skipping the pi's over 3's. I'm not writing them all, I'm writing a good mixture of them. If I were to write them all, on which I started to, then my table got too small and you couldn't read it. So for the sake of speed, we're just going to write down some of the values. Because remember, we don't need all the dots. If we put most of the dots, then we get a good idea of the physical shape of this. Okay, so let's see. At 0, the y value is 0. At pi over 6, which is 30 degrees, that's a half. At pi over 2, the y value is 1. Why is this not clicking? Click. There we go. And maybe now you can see why I picked these values. See why I picked those values? And they're all nice and friendly. I don't have any of those weird numbers. I chose the ones that were a half and 1 and -1/2 and -1 and 0. So 45 degrees got no love. Because it would have been √2/2, which is about 0.7. Which is a little bit harder to graph than 0.5. I graph 0.5 pretty straightforward and easy. So I said we're going to do this by hand, even though, did I give you a graph? Yeah, I gave you a graph. A little bit hard to see on the graph, right, where those values are. But if I, and by the way, if you were having to do √3/2 or √2/2, then just plug it into your calculator to find those approximations. Okay, so to do this graph right here, we're going to start at 0, 0. A little bit hard to see, but this is pi over 6. Your first tick mark right here is pi over 6. We're supposed to go up to a half, so put a red dot right there. And then pi over 2, which is right here, is supposed to go up to 1. And then 5 pi over 6, which is right here, we're supposed to go back to a half, so forth and so on. We get those dots. So once again, we're missing the 60 degrees and we're missing the 45 degrees, but that's a pretty good number of dots. If we play connect the dots, we can get a pretty good idea. Tonight for homework, it says, I want you to graph one cycle. Well, there's one cycle right there. Right? From start to finish, one cycle. I did this in Desmos. Desmos never puts arrows on the end, but remember, put arrows. Okay, yeah, we just did one by hand. Everybody good? Said it's going to be easy, quick class, and it's going to be an easy, quick class. That was the hardest part right there. Is there a way to make this easier? If you were faced with this many entries and you said to yourself, that's too many, how many would you actually need to get that shape? So Abby's either show me 4 or 5. Can't tell.
Somewhere.
Evelyn's saying 5. Seth's saying 4. So we're kind of in agreement. It's 4 or 5, right? So which 4? Which 5?
0.
I like 0, 0.
It goes all the way until the next
Pi
0,
2.
the 0, 1.
So she says do the x-intercepts. Evelyn?
No,
And then you would need
no,
1
from-
pi 2 and then the one at the very bottom. So you have.
Why did you pick those two?
Because you need the highest point and the lowest.
So she's
point.
saying pick mins and maxes and pick x-intercepts. So that would be 1, 2, 3, 4, 5. I like that idea. So guess what we're going to do? We're going to do that, right? Because we can kind of fill in between. It's going to be an approximation, but it's a pretty good approximation. All right. So in box number 2, we're going to write down some notes on the sine
Is
function.
that always good?
It's all the
If you,
parent
flip it
function.
over like this, like, down.
So for the parent function, yes, but as soon as you start flipping it, you don't have the parent function, which is what we're going to be doing today, by the way. All right, some notes on the sine function. First and foremost, you have to lift your pencil up to make the shape.
No.
So you're saying to go from here to here, I got to lift my pencil up? The answer is no. Therefore, that's what makes it continuous. There's no gaps, there's no holes, there's no jumps, right? So sine function is continuous. There are no holes, there's no gaps, no vertical asymptotes, so therefore it's all real numbers. I only did one cycle right here, but if I continue that cycle, it would just repeat itself left and right. So that means that you can, the domain is all real numbers. Point number 3 is, well, it only went up to 1 and went down to -1, inclusive, so brackets. So its range is between -1 and 1. You're like, haven't I written this down before? Yeah, we're just kind of putting everything together. Everybody was here yesterday, so we know about odd and even functions. Sine is odd, OEO, right? Sine is an odd function. Therefore, if we ever do a negative angle, we take the negative, we put it out in front of the word sine, and just do the sine of whatever that angle is, and then attach a negative to it, because it's odd. Remember that fancy word periodicity? How long does it take for itself to repeat itself? It takes 2 pi. Every 2 pi, it repeats itself. So it has a period or a periodicity of 2 pi. And then the last 2 points are the hardest ones to write. Okay, so let's see. It has x-intercepts. It has x-intercepts at, here's 0, 0 where it starts. Then it repeats itself back at pi, and then it comes back at pi, or at 2 pi, right? So it seems like it's repeating itself every 1 pi. 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Those are going to be your x-intercepts. If we go the other direction, -1 pi, -2 pi, -3 pi. Those are your x-intercepts. It only has one y-intercept, and that's at 0, or 0, 0. So I got x-intercepts, I got y-intercepts, and then I got mins and maxes. And I got an infinite number of mins and max. But the max is always 1, and the min is always -1. And where do they occur? Well, they occur between the x-intercepts. So if the first x-intercept is 0, and the second one is pi, and halfway between 0 and pi is pi over 2. So I get a max at pi over 2. And then it goes from max to min, max to min. So my next one, after 1 pi over 2, 2 pi over 2 is pi, and that's next intercept. That's not a min or a max. But then I go to 3 pi over 2, and 3 pi over 2 is a min. And you don't need to differentiate between the two. You just need to understand the max is 1, the min is -1, and they repeat themselves by odd values of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, and it just flip-flops between mins and maxes. And that's good enough for us right now. I mean, we could differentiate between which one is the max and which one is the min, but the reality is you simply need to know that maxes and min occur flip-flopping. A max and a min, a max and a min, a max and a min. Abby, you need water? Headache? Okay, cool. What was the big picture today? What are we actually doing? We're just graphing. These are just statements. These are good statements to understand that when you do these graphs, to make sure that the graph you wind up still maintains all of this. Now, when we transform it, the x-intercepts are going to change, the mins and max could change, but they're still going to have the same basic shape. Okay. Secondly, we decided that this was way too many things to graph. We decided to graph 5 points, and the 5 points are 0, 0. We know a max occurs right here, so this must be pi over 2, 1. This must be pi 0. This must be 3 pi over 2, -1, and 2 pi 0. So I want you to take this table right here on the right. And yes, I realize I should have made this as a separate box. This is the parent sine function. This is what you're going to use to do your homework when you're graphing a sine function. This is the starting point. And we all agreed that if we have those 5 points, we can graph it. So it's 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. We're doing sine and cosine today. The sine and the cosine look really awfully alike to each other. So make sure you not only have the table, the one here on the right, but you also have it listed as the parent function for sine. If you don't have this written, then you're over here to the left and you're taking the unit circle and you're graphing a whole lot of points. But the one on the left is like the shortened version about all you really need in order to graph these things tonight by hand. Everybody good? What?
So if they gave you like a graph already, and tell you to graph it.
No, they're gonna give you the equation and ask you to graph the equation.
Or like if they were to give like all the stuff already,
Mhm.
you could just look at the every 2 points. Just do that sense.
Yeah, you can do that too. Okay. All right, the next idea, recall that when we graph, our basic idea is we understand the parent function and we make changes to the parent function to make our new graph, the daughter function. Okay, so do you remember what the rules were? What happens if it's outside the parentheses? What does it affect? So you got parentheses and you got outside your parentheses. It's outside the parentheses. What does it affect?
Yeah,
It affects the y values.
yeah,
Either one. It still only affects the y values. What if it's inside the parentheses? It affects the x values. Okay. So they're going to use some variables to apply to the thing on the outside, the thing on the inside, and it's math, so we make it more complicated. So instead of using nice friendly letters, they're going to use Greek letters. Capital Greek letters, lowercase Greek letters, right? I don't know, it's math. We like to make things more complicated than it needs to be at certain times. Okay? Even though we're very lazy, we want to make ourselves seem smarter than everyone else around us. Okay, so what are the two easiest letters to use that you would recognize? Okay, so we're going to use A.
delta.
I wish they use B, but they don't use B. But they're going to use the first and the last. So they're going to use alpha and omega. But for some reason, they use capital letter A, but lowercase omega. And by the way, if you are in a Greek kindergarten and you're asked to sing your ABCs, guess what you sing? Alpha, beta, gamma.
How did delta go from a triangle to a
I have no idea. No idea. Right? But we're going to use capital letter A and lowercase omega. Right?
In church, did you sing the like alpha?
Yes. And I'll just say this. When I was growing up, not that I'm teaching religion or anything like that. When I was growing up Catholic, right? We'd have that saying from the alpha to the omega. I literally thought the priest was making a mistake. I'm like, should he be saying to A to Z? And like, I kept that to myself for a long time until I learned about the Greek alphabet. Like, oh, now I get it. I'm dumb. All right. I kept it myself. There's a saying for that, like, things that last into you didn't last in my adulthood, but like the things that last for a very long time that you make assumptions about that are completely, totally wrong. And then you find out the actual truth. You're like, wow, why did I think that? All right, so write this down. So the notation is going to be this. That's not a W, that's lowercase omega, right? So the thing on the outside affects the Y's, the thing on the inside affects the x values. Okay, so the thing on the outside is being what? Multiplied or divided or added or subtracted. So remember what that does? The effect of that is? In this case, the alpha. So what is the effect of alpha? What does it do? It's going to multiply what? The what? The thing on the outside affects what? The y. So what are you going to do with the a value? Say it's a 3. You're going to multiply the y values by 3. Okay. Now, if that a is bigger than 1, what is the effect on the shape? Thing on the outside that's being multiplied, what does it do? Wouldn't that be x's?
Oh, so then.
Yeah, so it's going to make it taller if it's bigger than 1. It's going to make it, and we call that stretching and compressing, right? Or shrinking, right? So it's going to stretch it if it's bigger than 1. That means up and down. If it's, what would smaller be? Negative, no. What would shrink it, compress it? He said negative and I said no, not negative.
Less than the y value. If it's like a fraction,
So that would mean between,
1 and 0.
if it's between 0 and 1 is what compresses it. And if it's negative, what is that going to do? A negative is going to make a positive y value and negative y value. So what's that going to do to the shape? It's going to flip it over the,
X axis.
write that down. So if the a value, if the alpha value is between 0 and 1, it's going to squish it vertically. We call that compression up and down. If the a is bigger than, if a is 1, then nothing's happening. But if a is bigger than 1, then it's going to stretch it both up and down. And if a is negative, then it's going to reflect over the x-axis. What is up and down? I thought about how to write that, and I was like, yeah, they'll understand that, but clearly no. Okay, so what's omega going to do? Yeah, but what do we know about things on the inside of the parentheses from previous transformations? Remember, shift left, shift right. What do we know about the things on the inside? It's always, things on the inside is always opposite of what you would think. Remember, if it says -4, we're supposed to actually add 4, right? So what is this W going to do? If omega, it's not a W, it's omega. If omega is between 0 and 1, that's going to stretch it. If omega is bigger than 1, and if omega is negative, flip it which way? This one says over the x. Write all that down.
What is the middle one?
Says then stretch up and down. Oh, omega?
The middle one, greater than.
And once again, this is nothing new. These are exactly the same transformations as it's been for all the functions we've done. The only difference is they threw an alpha and omega instead of an A and a B. To write a confusion. Cool? All right. I said cool.
No, it confuses me because I don't know if you're asking if we're okay with it.
No, I agreed. I was not being very specific there. I should have said, are we okay to go on? All right. So to actually do it, I mean, this is a big windup. It's something that's pretty darn straightforward and easy. You just simply need to remember the bottom part right here, what it affects, and do it. So here's the first one they're going to ask you to graph. I need to graph y is equal to negative sine 2x, right? Now, could you punch this in your calculator and hit graph? Yeah, you absolutely can to check your work. But the intent here is to do this by hand. Okay, step number 1, are we doing sine or cosine? So we need the parent function of sine, there it is. And then we simply take the pieces, what's the difference between this and the parent function? What's going on? What's extra added to this? There's a negative and then there's a 2. Is the negative affect the y or the x? Because it's on the outside. The thing on the outside, that's your alpha, is your multiplication. So what are we going to multiply? -1 times what? The x's or the y's? The y. So I'm going to take all the y values of the parent function and multiply by, well, that's easy. That's 0. And you're done. Did you screw this up? Yeah, because you might even know what you're doing, right? And then you put it in the wrong column. So pay attention to the details here. That affects the y value. Do you have to do the y values first? No, you can do the x values first if you want. If you're going to really screw it up, it's going to be the x values. All right, Priscilla, what's happening to the x values? Oh, well done. I could not catch you in a mistake. She said it's going to be the opposite, so therefore it's not being multiplied by 2, it's being divided by 2. So now I simply need to take all of my x values and divide by 2. Well, that's going to be 0. I'm dividing by 2. Pi over 2 over 2, which would be, if you did copy dot flip, maybe we need to do this by hand. So if I write pi over 2 divided by 2, 2 is really 2 over 1, do a copy dot flip, and that would be.
Wouldn't the 2's cancel? I know it'll just be.
You're supposed to do a copy dot flip.
Well, can you write it long ways then?
Sure, so tell me what to write.
Pi over 2
Yeah.
multiplied
By
by
this
2.
one flipped. By
No,
this
1
one.
over 2, so it'll be, so
Pi over 4. Okay. All right. This one's going to turn into, and this one, since we just did a copy dot flip, is 3 pi over, and then the last one, which would be not 4 pi, which would be just pi. All right. So that 2, we're going to, you're compressing it by a factor of 2 or dividing by 2 would give you those values right there. So once again, right, if you need to write it out, can't do it in your head, that's fine. But once you get used to doing this, you kind of can do the copy dot flip in your head. Okay, hey, great. I said this was supposed to be easy, but now what do we have to do? We have to graph it. I'm sorry, Ish, you're not going to see me do this, but here's the explanation. You're just going to write tick marks. So you ready? Watch me. I'm going to draw the x and the y coordinate. How many tick marks do we need?
5 at least.
I need 5 where the origin is 1. So I just need 4 evenly spaced tick marks on the x-axis. 1, 2, 3, 4. Okay. Going up and down, where are we going to? Look at the table we wrote. Going up and down, that's y values. What are we going to? The highest would be 1 and the lowest would be? So how many tick marks do I need? I just need 2, 1 above and 1 below. So 1 above, 1 below. Should you label? You can if you want, but that's all I really need to do. Now I just plug in the values. I've got 0, 0. I got my first tick mark, which goes now to, there's my first tick mark, and it goes to -1. So I put a dot right there. My second tick mark goes to 0. My third one goes to 1, and my last one goes back down to 0. And once again, that familiarity with, hey, I'm going up and down, right? It's symmetrical. I play connect the dots, and we said we only do 1 cycle. There you go. Pretty quickly done. Now, if you want to label the tick marks, you can. It would be helpful, right? I'll do it nice and pretty now, but the thing I just did by hand is all you need to do. So there it is, nice and pretty. Notice if we compare the blue, which is what we just graphed, to the original, the parent function, we can see that it's been flipped and it's been squeezed. That's what that 2 did. It's kind of, our period is no longer 2 pi. It's only going to pi now. Still starts at 0, 0, winds up at pi 0. But our original, the parent function, goes from 0 to 2 pi. All right, you tell me, easy, medium, hard? Yeah, pretty easy. Okay, for the sake, what time we get out of here? Anybody? I don't know.
wait.
10:40? We got 6 minutes left. No, we got 2 minutes left. So guess what the last thing you need to do in order to do the homework? You need cosine. And do we want the long one or we want the short one? So I'll give you the short one, which is right there. So 0, 1, pi over 2. Hey, look, the x values are exactly the same as the sine. It's the y values that are changing. Now we can do 1 and call it a day. All right. Let's do that one's kind of like the previous one. Let's do this one. All right, so what's happening? Right, but what's going on with this one? The y's are being by, and the x's are being, ooh, she didn't say divided by 2, she said multiplied by 2, because remember, it's always the opposite. Okay, so we take our parent function, this is cosine, don't do the sine, do the cosine. We take the y values, we multiply by 3, and then we take the x values and we multiply by 2. So that would be 0 multiplied by 2, which would be pi, 2 pi, which would be 3 pi, and then 4 pi. There you go. I'll leave that up there. And that's it. And then we graph that. Remember, graph it the easy way. You just need a couple tick marks and you're good to go. All right, that will do it for today.